Joining us now, Adrian Owen. He is Canada Excellence Research Chair in Cognitive Neuroscience and Imaging at the University of Western Ontario. And the second you open your mouth, people are going to know you're not from here. We inherited you. We brought you over from the UK. And more on that later, on why you'd want to leave there to come here. But first of all, welcome.
Thank you very much.
It's nice to meet you. Let me start by reading something that was in the New York Times about a year ago, and then we'll go from there. On the issue of unlocking the human brain. He emerged from the car accident alive but alone, there and not there. A young man whose eyes opened, yet whose brain seemed shut down. For 5 years, he lay mute and immobile beneath a diagnosis, quote, vegetative state, that all but ruled out the possibility of thought, much less recovery. But in recent months, at a clinic in Liège, Belgium, the patient, now 29, showed traces of brain activity in response to commands from doctors. Now, according to a new report, he has begun to communicate. In response to simple questions like, do you have any brothers? He showed distinct traces of activity on a brain imaging machine that represented either yes or no. Now, this New York Times article is referring to research that you did. This is groundbreaking stuff. And I guess let's just start very simply. How is it possible that someone in a vegetative state can communicate?
That's a very good question. Well, what we've been looking at is whether in some of these cases, and it isn't everybody, but in some of these cases, in fact, they're not really in a vegetative state, they're just unresponsive. So they are incapable of generating any responses.
What's the difference?
Well, for example, how could I possibly know that you are conscious? Now, the only way I can do that is by asking you to generate a response. You and I are having a conversation. On that basis, I know that you must be conscious because you're asking me questions and I'm giving you answers. We're having a conversation. But if you were disabled, if you were entirely paralyzed, and you were unable to generate those sorts of responses, it would actually be impossible for me to know that you were aware, because you would be entirely stationary, you wouldn't be producing any kinds of responses.
So I might be conscious but non-responsive.
Yes, now that's the worst possible scenario. And it's one that we now believe does occur in a limited number of cases. And what we've done is to use brain imaging to try and get around this problem of needing somebody to respond. So instead of me asking a patient a question, are you aware? We're asking their brain a question. We're getting them to generate responses with their brain to indicate that they are actually aware.
Okay, let me ask our director, Michael Smith, to bring up that graphic of the brain scans, and you can walk us through these and tell us how, well, you see on the left is a yes and on the right is a no, and we have different colors, orange on the left, blue on the right. Tell us what we're looking at.
Okay, well, the approach we used is to get the patient to imagine certain scenarios. Now, one of the wonderful things about the brain is that areas activate if you think about doing things that are the same areas that would activate if you were actually doing those things. It doesn't work for everything, but there are a few areas of the brain that are very responsive in this way. Now, one of them is called the supplementary motor area. It's right here in the top and in the middle. And if you imagine waving your arms around or moving your arms, this area will activate, exactly as if you were moving your arms, because it's involved in generating or producing movements.
So you don't even have to do it, the brain will show that it's happening.
Absolutely.
Okay.
So a few years ago, we set about asking patients who appeared to be vegetative or non-responsive to imagine moving their arms. Now, the sort of idea that we would use to get them to do this, we'd say, imagine you were playing a game of tennis, because whenever you do that, people start to think about doing something like this. And we found that some patients, a minority, but a significant minority, would produce activation in this area when we asked them to imagine playing tennis. And then the activity would stop when we asked them to just relax. Now, think about it as though I was saying to the patient, move your arm if you're aware. What they're doing is they're activating their brain if they are aware.
Okay, Michael, bring the shot up again. So you've asked presumably some questions of somebody that prompted a yes answer.
Absolutely. So in this situation, we had a patient who, as you've already described, had been assumed to be vegetative for 5 years. And we said to him, if you want to say yes, imagine that you are playing a game of tennis. Now at the top there you can see what's labelled as a control. That's a healthy volunteer. On the left-hand side, that's what happens in a healthy volunteer's brain when they imagine playing tennis.
Who is aware and responsive.
Absolutely.
Okay.
Now when we ask the patient, who's below that, a similar question, in this case we said, have you got any brothers? Exactly the same area lit up in his brain. And that's because he wants to say yes, because he did have brothers. So he's imagining playing tennis in order to convey that response.
And those areas of orange shading are similar enough that you can come to the conclusion that, yes, he's aware, he's conscious, he's responding, although not physically responsive. Is that right?
That's absolutely correct. Now, you wouldn't want to do it with a single response, and it's important to emphasize this is not something that just happened once. This is something that obviously we had to replicate to make sure that it was robust. We had to make sure that when we asked him a question, he would produce an answer that was factually correct. So afterwards we went and we checked the responses. And we had other things. He had one type of brain activity for a yes and a different type of brain activity for a no. So after a while of doing this, you can be pretty sure that you're communicating with this patient.
It's not a fluke, in other words.
Absolutely. Despite the fact that behaviourally, you know, if you were to examine him clinically, he will generate no responses.
We are at the end of the first decade of the 21st century, and some people might be wondering, why has it taken us this long to figure that out?
Well, that's an interesting question. I mean, one of the things that's really changed recently is brain imaging and what you can do with brain imaging.
We've had that for decades, though, have we not?
We have. One thing we haven't had for decades is what we call real-time brain imaging. Up until just 2 or 3 years ago, you would scan somebody and it would then take perhaps 2 or 3 days to analyse the data. Now, in this sort of scenario, that's absolutely useless. To find out 3 days later that the patient in the scanner conveyed a yes, you can't have a conversation like that. What we have now, and really this is something that's come about very recently, is that the patient can still be lying in the scanner and we can see immediately that they are conveying a yes. And of course that allows us to know that they are aware and to then start to tailor our subsequent questions to the previous answers. It's an extremely important technical advance.
Your research opens up a Pandora's box of ethical considerations and questions. And, I mean, let's start at the top of the list, pulling the plug, for example. We've always been under the assumption that you could pull the plug on a so-called vegetative patient because there's nothing going on there. No responses, no nothing. Your research suggests there is something going on there. How do those ethical questions shape the research that you're doing right now?
Well, it's very early days, and it's very important that people realise that this doesn't mean that all apparently vegetative patients are in fact aware and are able to generate these kinds of responses. So far, we have only found that 4 patients of a group of 23 were able to do this. So, you know, as I said, it's a significant minority, but it's not all patients.
Do those 4 have something in common that the others don't have, and therefore they were able to do this?
That's a question that we're only really going to be able to answer when we've scanned many, many more patients. Right now, no. I mean, some of them have been in a vegetative state for a short while, some for much longer, some have been victim of a road traffic accident, others have had other types of brain injuries. So there doesn't seem to be any particular pattern at the moment.
Okay. Back on the ethical question, though.
Yes. Now, this is something that I think is going to unfold gradually, and there are many other challenges that we need to meet before we can really work out how to use this type of approach. I mean, the first is that we can spot patients who are aware even though they appear to not be aware. We haven't yet solved the problem of how to spot patients that still slip through the net. For example, if I have you in the scanner and I think that you might be vegetative and I ask you to imagine playing tennis, if you were deaf, you wouldn't generate that response, okay? Mm-hmm. Now that wouldn't mean that you were in a vegetative state, it might only mean that you were deaf. And there are all sorts of scenarios like that where a patient might not generate a response, but it doesn't mean that they are vegetative. And that's a very important question that we need to tackle over the next few years.
Possibilities are endless here, aren't they, about whether you can or can't get a response and so on.
Absolutely. But I mean, another issue to do with the ethical considerations here is that just because you know, I don't want to shoot myself in the foot, but just because a patient can generate a yes or no response doesn't necessarily mean that they have the necessary cognitive faculties to answer really tricky questions about life and death. I mean, there are people walking the streets who can answer yes and no questions, but we wouldn't let them make decisions about whether they lived or died. So, you know, we need to go much further, and we need to work out how not only can we get somebody to answer questions, but we can explore their inner situation. What sort of situation are they in? What sort of, you know, how are their attitudes? You know, are they really aware of what it means to live and die, and these sorts of things? And that's going to take a little bit of time.
Well, yes, that will take time, but one thing that won't take time is for, you know, people watching this who may, for example, be pro-life. They will not wait any time before saying, aha, see, we told you so. Therefore, there cannot be any human intervention, pulling plugs or anything like that. Conversely, on the other side of things, there may be people who say, you know, you're offering some false hope to people. There's really, you know, nothing going on that you can categorize. It seems fairly random at the moment. How do you respond to both of those kinds of allegations?
Science moves along, you know, and just because decisions may have been made in the past that might retrospectively seem wrong, or we may think that we would now make a different decision. I mean, we have different tools for approaching these problems. You know, these things change all of the time. I don't think the work that we have done has demonstrated that, you know, anybody has been allowed to die who should have previously been allowed to live. I think what we've done is we've created a situation where some patients, and again it's a minority, who might be able to play a role in their own destiny, and that may be in the type of medication they receive, or, you know, what happens to them in the longer term, can now have a voice, can now play a role, and that's got to be a good thing. It isn't the be-all and end-all, it isn't the complete answer. We haven't solved the whole issue of what are we going to do with these patients, but I think we've made a really good start. And one thing that I think it demonstrates is that these patients should be having brain imaging. Up until this work, it really wasn't routine. It wasn't a routine clinical procedure that patients have functional brain imaging. We've now shown that it can add something that standard bedside clinical assessment can't. And so I would say that an important message is we should start doing that now. But we should start doing that now on the understanding that most of the patients that we've tested are still vegetative. They still appear to be vegetative afterwards. So it's not as though we've shown that, you know, all of these patients are in fact in there and communicative.
Well, one thing we haven't discussed, and I guess I don't know whether your research touches on this, is whether anybody wants to live like that. Whether there's communication going on or whether there isn't, or scans are happening or not. Is that a condition in which anybody wants to live? Do you have a view on that?
Well, I don't think we can answer the question until we've really explored in some of these patients, you know, what it's like to be in this situation. Because, you know, we all have these feelings that it would be the absolute nightmare scenario. But there's actually very good literature showing that patients who have what's called a locked-in syndrome, and I'm sure you've heard about these, the patients that sometimes can just move an eye or move an eyebrow, and that's their only method of communicating. Some of those patients, in fact, many of those patients do not want to die. They would rather stay in that situation than die. Now, that seems rather odd to me, and I know it seems rather odd to many people. We all would imagine that if we got stuck in that situation, we would want to die. But we can't know that, and the only way we can know that is to really, you know, investigate these patients and talk to them. And we found a way that we might be able to do that in some of them.
What's the next thing you want to discover in this area?
Well, one very important thing is that the brain imaging method that we've used is absolutely excellent for identifying these patients. It's not going to be very good in the long term in any individual case. It's a very expensive scanner. We can't move the scanners around to the patients, and obviously many of these patients are seriously ill and can't be moved around themselves. So we're trying to develop more portable, more economically viable and efficient systems for communicating with those patients that we managed to identify as not being what they appear to be. So I think that's the next big thing, and I think we're going to do it. I think it will probably be using a different type of technology known as EEG. I think if we can get the EEG right, and we can do the same thing we've managed to do with the MRI, that is identify that patients are conscious and start to communicate with them. That will offer a much more portable and affordable solution that might ultimately end up with a device that really would allow somebody to have daily conversations with their loved ones.
Any potential applications here for Parkinson's or Alzheimer's or ALS, something like that?
Well, it's very interesting you say. ALS is a condition that in its later stages often results in locked-in syndrome. The progression of the motor symptoms that are associated with the disease is out of step with the cognitive system. So a lot of this technology and these approaches have been developed in late-stage ALS patients who are no longer able to generate movements but still have their cognitive faculties intact. So I think it's very applicable to that group of patients.
Okay. That's the research. Now I want to talk about you. Because, well, let me just read this. This is off the Government of Canada website. The Canada Excellence Research Chairs Program, you're one of them, supports Canadian universities in their efforts to build on Canada's growing reputation as a global leader in research and innovation. The program awards each of the some 20 chairholders and their research teams up to $10 million over 7 years to establish ambitious research programs in Canada. Canada Excellence Research Chairs are tenable for 7 years and are not renewable. The chair positions are targeted at the world's top researchers to develop ambitious research programs within the 4 priority research areas outlined in the Government of Canada's Science and Technology Strategy, introduced in 2007. We got you from Cambridge, UK, one of 19 academics awarded in the first ever round of these Excellence Research Chairs. And I want to know how we did that. What pitch did we make to get you to leave there and come here?
Well, there are a number of different answers to that question. The first one is purely scientific. Western is world-renowned for its cognitive neuroscience, its brain imaging, its neurology, its genetics, and as I've already hopefully demonstrated, the sort of work that I do is very multidisciplinary. It draws on all of those different fields and different areas of expertise. So I can't do what I do alone. I need access to all these different types of people. I need collaboration and cooperation.
You didn't have that in Cambridge?
I certainly didn't have it in Cambridge to the extent that it was presented to me at Western. I mean, at Western, I mean, perhaps actually giving you some background to the Canada Excellence Research Chair program will help here. So this was a 2-stage process. In the first stage, and this was long before I was even a twinkle in Western's eye, they put together an application. It was a Canada-wide competition to put together an argument for what sort of person or what sort of team they would need to realise existing potential. And Western put in an application that focused on clinical neuroimaging as being an area that they could excel in if a few existing holes were perhaps blocked. They were shortlisted on that basis, and in the second round of the competition, they found me. They approached me and I fitted the bill. So in many ways, you know, Western came to me, and at the point that they came to me, a lot of the groundwork had already been done. They had already worked out how they could provide excellent imaging facilities. They'd already worked out how I would be surrounded by extremely good cognitive neuroscientists and engineers and physicists and clinicians and all of these other people. So actually, it was a much easier decision to make than you might think.
Well, that goes against conventional wisdom because maybe this is our inferiority complex, but nobody leaves the mothership for the colonies, right? And yet that's what you've done.
Well, I've come to a much better situation. You know, scientists are selfish, really. They just like to sort of get on with their research. And, you know, to do that, it requires infrastructure, it requires that you have other people around, and of course it requires funding. And this was all laid out to me in a very enthusiastic and cooperative way, and Western made the argument that I could do what I was doing in Cambridge much better at Western and take our research to the next level, and I believe I can do that.
And what do the folks at Cambridge think about your decision?
Well, I don't want to speak. I really don't want to speak for them. You should probably ask them yourself. I mean, it was an interesting time to leave Cambridge. You know, I think the research that we were doing had a number of successes in recent years, and I think some people did question, well, this is a bit odd to be leaving at that point. But You know, I could see that we needed to move on and we needed to do other things. And to do that, really, I need to have access to other types of technology. I mean, imaging in particular is very strong at the Robarts Institute, as you know, at Western. The situation there, purely in terms of the equipment, doesn't compare to the situation I've left in Cambridge. It's far superior technology and expertise at Western.
But the grad students, did they look at you and saying, "What are you, nuts? What are you thinking here?"
A lot of them came with me, actually.
They did?
So they obviously didn't think it was such a bad move.
Okay. Is there, let me put it this way, there's a, I'm going to give you the baseball analogy. A lot of teams that don't have a lot of money develop their own players in the farm system. And then when they get up to the big leagues and they finally become superstars, they leave and they sign on the dotted line with the New York Yankees, for example, you know, the big ticket free agents. We seem to have done that here. We seem to, you know, strangely enough, Canada seems to be playing the role of the New York Yankees here, snagging the big free agent. Does it say something, though, about our inability in this country to develop our own people, you know, in the minor leagues, so to speak?
I don't think it says that at all, actually. I mean, I think, you know, science is very international now. Scientists move around all the time. There were many Canadians in Cambridge working with me. But I think what the Canada Excellence Research Chair programme has done is to produce a situation that can kickstart growth in a particular area. So the money that has been provided will allow me to train possibly 10 postdoctoral students over the next 7 years. Many of those will be Canadians. We can train many graduate students. So at the end of this 7-year period, we will have trained a whole generation of young people in cognitive neuroscience, in brain imaging, and in my particular area of interest, disorders of consciousness. So, you know, I'm hoping, and I think that 7 years from now, you'll see the fruits of this growth, and a lot of that will be Canadian. But you know, you have to start somewhere, and I think this is a really great way to try and do it.
And your wife's a scientist as well, yes?
She is.
And she's involved in this as well?
She is. She doesn't work directly with me. She's a cognitive neuroscientist with expertise in imaging and music.
Huh. And so obviously she's along as well and able to do her thing here as well?
Yes, I mean, this is also a very good move for her, for many of the same reasons that it's a good move for me. She has access to an excellent music faculty at Western. She's also somebody that draws heavily on the brain imaging expertise at the Robarts Institute and the cognitive neuroscience at the Centre for Brain and Mind. So again, it's an excellent move for her.
And she's so much closer to her family now that she's over in Canada.
That's true. That's true. Her family are from the United States. So.
Where in the United States, though?
They are all over the place. They're in Salt Lake City and in Boston and in Chicago.
Oh, okay.
So we can get to all of them easily now.
Boston and Chicago fairly easily. I would think Salt Lake's still a bit of a schlep.
It's a while, but it's a lot shorter distance than coming from the UK.
Tell me this, in our last few minutes here, I want to talk about something that we really pulled our hair out in this country over, I guess about 20 years ago. There was the sense that we were falling behind in a lot of these areas, and because of it, I guess both the business and the government commitment to these files was not what it is today, and scientists left. We lost a lot of people to the United States, for example, and there were articles all over the place about you know, woe is Canada, the brain drain is killing us, we're losing all of our best and brightest. We seem to be on the opposite end of the brain drain right now. And I wonder, you know, as you left, did you see articles in the British press with them fearful of a brain drain from the UK to other places in the world?
Absolutely. I mean, I think I was quite lucky actually to leave when I did. I mean, there were, around the time that we were thinking of moving to Canada, there were lots of media reports about cuts in funding in the UK. Now, it turns out that they were not as serious as anticipated, and funding has not been cut to the level that people feared. But you know, it's still not a good time at the moment scientifically to be in the UK. And as I've said, scientists will move around. We need funding to do our research, and it's natural that people will go to places where that research is being done successfully. And I think that is why this strategy that Canada has taken to invest in areas that have a particular potential and to build new strengths and centres of excellence is something that I think will be very important in determining where the best research will be going on.
People who've lived here a long time, though, and who remember those brain drain days, may be surprised to hear that we're the magnet now, pulling people in from all over the place. Do you still see signs in your work or around London, around Ontario, of people who can't quite get it through their heads that we're actually kind of a catch these days in Canada in terms of the scientific world?
I think no, I don't actually. I mean, I think these things will change. Obviously, they will change slowly. But, you know, in moving to Western, many people, as I've said, have moved with me. We have other faculty positions to offer. It's a very bright future for doing scientific research at Western right now. That's definitely not the attitude I've come from in the UK. The atmosphere there is a little bleak at the moment, and people are not sure where things are going to go, and I think it's just going to get better and better here.
Terrific. Adrian Owen, Canada Excellence Research Chair in Cognitive Neuroscience and Imaging at the UWO. Good of you to visit us at TVO tonight. Thanks so much.
Thank you.